The second question here says, 2-point charges exert on each other a force F when they are placed small r distance apart in air. When they are placed capital R distance apart in a medium of dielectric constant capital K, they were exerting the same force. Then the distance capital R equals. Now, the first case in this question refers to a situation where 2-point charges Q1 and Q2 are placed r distance apart, small r distance apart in air. So we'll look at that case first. And in that case, the electrostatic force Fe will definitely be equal to 1 by 4 pi epsilon naught Q1 Q2 divided by small r square. Now, in the second case, these two charges were kept at some separation capital R in another medium of dielectric constant K. Now, you'll have two charges Q1 and then you have Q2. Separation is capital R. In that case, the electrostatic force in the second case, Fe dash, will be equal to 1 by 4 pi epsilon naught epsilon R, which here is K, which is basically the dielectric constant. Relative permittivity is exactly what you mean by the dielectric constant. You have K here, and then you have Q1, Q2 divided by capital R square. Now, the question tells us that both these forces are equal. Now, in that case, we need to find an expression for capital R in terms of small r. To do that, we'll equate these two expressions for force, and the question tells us that these two forces are equal, so we are allowed to do that. So we have 1 by 4 pi epsilon naught into Q1 Q2 divided by R square will be equal to 1 by 4 pi epsilon naught K into Q1 Q2 by capital R square. Q1 Q2 gets cancelled off. 1 by 4 pi epsilon naught cancels off from left and right. So finally, what we have here is 1 by small r square is equal to 1 by K capital R square. We need to find an expression for capital R in terms of small r, and that will be capital R square will be equal to small r square by K, or I can say that finally capital R is equal to root of small r square by K, or R by root K. Now, this is your final answer. Let's match it with the options. Option A is the correct one, which says capital R is equal to, distance capital R is given by small r divided by root K. So option A is the correct answer.